Good afternoon, everybody. I hope you had a good lunch, and welcome to our session around migrating Windows stacks using SQL high availability and DR strategies. So my name is Lutton, and here you have Scott McDonald. We both belong to a great AWS team called Professional Services. We are the hands-on arm that helps you guys, helps our customers and our partners to implement these type of solutions. We both have, I believe, over 20 years of experience each. Scott has been working on the massive DR scenarios, I think most of his life, as far as he can remember. I've been working on many different types of Microsoft workload deployments and architectures. In my past, I worked with various teams on that side, and I kind of intensely work on that also now with AWS. So what are we going to be talking about is what we believe to be a best way around performing migrations, specifically for Microsoft workloads. Now, this also you can apply to open source Linux workloads and so on, but we will focus on the Microsoft ones, and we do have a demo as well to show you on how that works and all that. So, idea is to move Windows stacks to AWS fairly quickly. We want to do it with the least amount of risk possible, and how to utilize a multi-site DR strategy to do so. We're going to show you a live demo of the cross-region SQL Server failover. We're going to go through a deep dive also into the code. We're going to touch a bit on the code of all the things. We will show you also where you can get most of the scripts that we actually use, which is in fact CloudFormation. So, since this is a level 400 session, we expect you guys to know something about AWS, to know something about Windows too, which would be great. But we will touch on some basics now in the beginning. First thing and foremost, those of you that know us and know us well, we have a very strong DevOps culture. We are very much about automation, very much about automating every aspect of provisioning, infrastructure, applications, solutions, configuration services, and so on, right? As Einstein says over here, if you want to run successful on the cloud, you have to automate all your infrastructure, and that's right. It's really the speed of migrate, or rather of deploying your infrastructure, your services, and everything that matters really the most. And this is where you get your agility. This is where you get a way of actually deploying all the resources fairly quickly. It promotes innovation, right? With us, you can use as much of the resources as you need whenever necessary. You can switch it off when you don't need it, and automation makes all this even more cost-effective for you. But what does also automation does, on the other side of things? This is going to be a verbatim quote from one of the tweets that I've seen about a couple of years ago, and it goes, "To error is human, but to propagate error automatically to all of your servers is called DevOps," right? So, so that's the flip side of things around that DevOps and full automation can just as well, irrespective of how available and how resilient your architecture is, DevOps can bring you down in a second. So it's really important to have the right, the right aspects of automation. And consider that when automating your infrastructure. So, infrastructure as a code. So that's effectively at the source of it all, and the very basic service for us is AWS CloudFormation. we use it to build and manage repeatable infrastructure programmatically. It enables us also to reconstruct, everything, business from the source code, repo, and backups. However, there are the services that we use services such as code deploy, code pipeline to orchestrate, and code commit or Git and other repositories to store and version all of the stuff that we have. Obviously, we can include things like Jenkins and so on for build and various other platforms for test stages and so on. So what does that look like specifically for Windows stack? So the entire Windows stack can effectively be represented by a CloudFormation template. As you know, CloudFormation template has its properties that you specify, and those properties define effectively what and how the CloudFormation will go ahead and deploy things. And the resources being the most important aspect, which actually defines the resources that you're deploying, right? I'm going to dive deep too much into how CloudFormation works. I'm hoping you guys already know, unless if you don't, you can look up our documentation. But you can effectively, the way we do from an operational perspective, that we use version control of specific system, like I said early on, either code commit, Git, GitHub, or anything, something similar like that. And then that's where we version, individual templates and any subsequent updates to those specific templates. The stacks are we usually separate those into specific layers, like a networking layer, security layer, and so on. You don't necessarily really want to include everything in the stack, and you want to separate those out, specifically if you have that little property tick to actually go ahead and roll back all of the things that you've provisioned, right? So there's that feature also with CloudFormation that'll, if it encounters some sort of an issue or an error, it will roll back everything. Now, you don't want it to roll back your entire infrastructure. So as such, you want to separate those out and create something we call, use nested stacks and use a master, effectively, template that executes all of these in sequence. Now, CloudFormation is JSON-based, as some of you know, and you can use YAML. As such, it's explicit, it's schema-based, and as such, basically it's an instruction to our service on how we should be provisioning your infrastructure. And because, it's in its output format, is because there's a lot of things that you can use to build it out. There's open source projects like Troposphere, you can use Terraformer, there's a lot of others that you can use it to programmatically build it out specifically, and I encourage you to look at those. So once through automation that individual templates or entire template stacks get actually, or a number of master templates with stacks get pulled out, then they go ahead and based on the properties that you define, and quite simply, that can be dev, test, or prod, you can go ahead and deploy those out into AWS environment. What's great about this? First of all, that you don't have to redo a template for every single environment that you have in there. Second of all, and that the actual validation with respect to the properties can define how your infrastructure gets deployed. Second thing that is great about it is that should you, for whatever reason, need to provision equivalent environment, and this now forms the basis of the disaster recovery. You are not sure whether something is going to run properly, whether it's going to, the updates that you're applying, whether they're going to affect adversely your particular solution. The base use of, some of you might be familiar with blue-green deployments, where you can actually just deploy just equivalent environment, and then you can cut over your DNS to that environment from one to another if necessary, and so on. And incidentally, this forms forms part of the most basic of the DR and probably the most relaxed of all the DR strategies, and the cheapest one, which is based purely on the backup and restore, and then shifting those over to, let's say, AWS or another location, and then in this case AWS, and using CloudFormation to go ahead and deploy the resources. So how does it relate to Windows app migrations? Well, basically, in more traditional sense, I don't know, maybe our experiences may vary, but I will share with you my experience, on migration specifically with Windows workloads, whether those include migrations of SharePoint, of Exchange, Dynamics, of Link, Sky for Business, or anything, and all those type of different migrations, is that the biggest problem is obviously the downtime that you're going to incur to the business. And a lot of these solutions, specifically, they have their own ways, specific ways on how you migrate them and so on. However, it's always a plan that is very one-dimensional, in a sense that you have a migration plan, and you have the runbooks, and the runbooks go ahead and outline each step that everybody needs to make, approximately how much time it's going to take them. And then what is the rollback procedure for every step in that thing, right? And who's responsible for it, and who's the second contact, and so on. And then there's a downtime mitigation. Downtime mitigation usually entails, specifically with applications, which is the theme of today's talk, switching it over to read-only, and then effectively not allowing business to work with it, but allowing them to at least access the data in the meantime, and then eventually then allowing them to do so. We thought when we started, with building effective DR scenarios for a lot of our customers, it just made sense, because to use those DR scenarios as a case for migrating the workloads as well. So, and that's usually a first step for a lot of new customers. They go ahead, they want to use AWS specifically for disaster recovery. And then they want to slowly kind of migrate over, and what that happens is that once they have full-blown, hot or warm DR standby, then they flip the switch over to that one, and then they just decommission what they have on this side. What we're going to show you is that how you can then further, flip over to other regions and so on. I had opportunity to do a couple of more sessions early on, and in those I discussed some of the common scenarios also for DR. And some of you might remember, I see some familiar faces. But one thing that I talked about is that, first of all, with most of the customers, once again speaking out of experience, they will, if they even had a decent DR solution, which was either, based on the, their data center in a colo or another data center that was, let's say, 10 to 15 miles away. First question that I would ask them is like, okay, well, that sounds great. How often do you test it? And it says, we never test it, right? And that was a little bit ridiculous. I was like, well, how do you know that it works? It says, well, we know it works because it functions, and we don't want to test it because we think we're going to break it if we test it. It's like, I was like, well, I don't think that's a DR solution then. I think it's just a waste of time and resources, but and money as well, right? So what we do is that we make sure, first of all, to put in proper disaster recovery scenarios, and depending on the customer's RTO and RPO, and I will discuss those in a bit now. But more importantly, we have worked with our customers, we are partners on building a lot of projects, as some of you may be aware. Something like what we've built with, what basically Netflix built in collaboration with us is Chaos Monkey and the Simian Army. And that's a great tool to use to go ahead and simulate downtime scenarios and test out these type of DR scenarios. So how many of you are aware of Chaos Monkey? Everybody, excellent. Okay, good stuff. so that's really great. And then, Simian Army has everything from Gorilla that shuts down different regions and so on, and down to Monkey shutting down the instances, and Janitor Monkey and so on, right? So what's great about it, once we actually build that out, once we build out a DR scenario in AWS, and once we actually have that, even like I said, if it's most rudimentary aspects such as using CloudFormation, and by the way, the CloudFormation, once you actually automate, the deployment of your infrastructure, guess what? The question is not anymore how fast can I actually deploy my entire infrastructure. The question is how fast can I copy the data over, right? And that's really where it gets to. And even in that, in that sense, like once we do that, once we do the first DR, the potential of migrating you to any other places and so on is a lot easier and a lot faster, right? It's really just another click of a button and so on. Another aspect to consider specifically with the workloads and all that, that's sometimes you have the resistance specifically from users around migration and so on. I think easing it into as a first step to be a DR instead, and then kind of cutting over later, it might be an easier way to introduce migration and to kind of do change management from an organizational perspective. So, multi-site DR migration framework. So what we're going to show you specifically, we're going to show you a DR scenario between two regions, specifically the US West 2 region and the US East 1. What we have, and I'll show you basically the setup that we have and what we're using. But we're going to replicate the database on backend. We're going to duplicate the application stack on front. What that really means is that effectively we have always on availability group that is going to be with entire WSFC cluster span across two different regions over a VPN that we configure through OpenVPN, and I'll get more into it. And we basically going to have two servers running, basically two always on availability nodes running in region A in this case, and another two in region B, which will be all in effectively altogether 4 nodes. Second bit would be just replicating the actual application stack, which can be any .NET application, which could be your SharePoint Dynamics application, and so on. And then you can do it where you kind of strip it down to the bare minimum of what it needs to run, and then use auto-scaling service and launch configuration to bring up, once you flip over, to bring about the additional instances or the additional web front ends and things that you've stopped already, or whatever the case is, that are dormant and waiting to come back up. What we suggest is to failover traffic in small increments and test repeatedly to iron out any issues. So I know this sounds very simplistic when I say it the first time, but there could be other issues. And what I found being I don't know how this is going to sound, but I found working with Microsoft Stack in general to be a little bit more difficult than the open source stack and all that sort of stuff. There's a lot of nuances, there's a lot of protocols, there's a lot of automation that they do on their side that you need to consider, right? The way they actually handle certain protocols, the way they handle, what ports they need and so on, and what works better and what doesn't. And I'll discuss some of those. We have come across all these issues when we built this specific solution. And then once you're ready, you just completely fail over to AWS, like I said early on. So these are the basic. You'll find this in our documentation. You'll find this, literally anywhere. This is how we kind of separate the different disasters recovery scenarios, backup and restore, pilot light, which is basically your most common denominator plus the data replication between. Backup and restore already discussed, and then warm standby and really the multi-site one. And multi-site and warm standby can kind of work hand in hand with respect to that. There's once you establish a DR model, what really and you get it up and running and stuff, which we will do for you just now. All you really need to do is just tell your ops team to go ahead and either switch over your Route 53 to the applications on this side, or force a health check to actually go ahead and flip over to the AWS deployment or AWS hot standby. If you're working with stateful applications, there are some issues around, how, if you want to do something like a latency-based routing between the applications. But if you're working with stateless, it's very easy, right? You don't have to worry about the state, right? So you can just send depending on where they go and so on. What's great about when you do it on multi-region level is that if you're expanding, and this is the reason as well for a lot of our customers migrating, on multi-region side of things, is that if they're expanding globally and they want to expand their application footprint in AWS globally, this is really, they start establishing the same DR scenarios via VPN, the way we're going to show you now, and on and on and on, and they keep on cutting it over. And then you can, in most cases for stateless applications, they use latency-based routing. So people from East Coast will, the Route 53 will send it this way instead of sending it to the West Coast and so on. So this just becomes effectively a DR exercise. And guess what? Because you've actually implemented a proper DR strategy, and because you are often testing your DR, and because you just ironed out all the issues around migration, and you can just seamlessly shift over to the other one, right? You don't have to go through all this nonsense that we had to go through before when we go and employ more traditional migration strategies, and that makes it a lot easier. And let me get this straight. I mean, for a lot of people might ask, okay, but is this equivalent to my DR strategy that I currently had? Do I have to do like a multi-region strategy? In most cases, right, your DR strategy could have been, or for example, where you had a DR, like I said earlier, in a separate data center was like, let's say 10, 15 miles away. You'll find that just doing a multi-AZ deployment in one region is actually better than that. So because, just to remind you, every availability zone on our side is a cluster of data centers that is geographically displaced from one another, and they're on a different fault plane with respect to earthquakes or natural disasters, on a different flood plane, and so on, making sure that there's no disaster that can potentially bring down more than one availability zone. And as such, multi-AZ deployment alone is probably equivalent, if not better than previous DR solution that you could have had. I'm not sure, I'm guessing, but this is kind of from, speaking from experience. So we're going to jump into the demo. So what do we use for the demo before this thing goes on? We use the AWS white paper on multi-AZ SQL Server. You can go ahead and download this. Even better, if you go ahead and search for AWS and Quick Start, and you literally go down, you select Microsoft, and we'll show you that shortly, and go down to deploy the SQL stack, we will actually have, not only will you have access to the CloudFormation for deploying this particular thing, but you will also be able to deploy it in your own account, with a one-click button. This is just a multi-AZ SQL for deployment. This is not the multi-regional one, which we're going to show you. So we duplicated that model into another region, right? And then we tuned the VPN tunnel and routing between regional VPCs via the VPN tunnel between the two regions. And then we deployed basically DC replicas on the other sides because, as you know, Windows specifically enterprise applications are very chatty and they need they need local DC servers. Yeah, we created a Windows Server failover cluster and where we installed, obviously SQL and configured always-on availability groups. So what does that look like? Hope you guys can see. Specifically in our setup is that we've actually done it through, we've used what you see here as a NAT instance. And we'll show you in the code. And what we're going to show you is the difference than what you're going to get when you actually go and see the documentation online plus the quick start that I mentioned earlier. So we've deployed OpenVPN as part of the CloudFormation template and established basically a VPN connection between NAT instance in region A with a NAT instance in region B. One of a couple of things that we've learned the hard way, some things the easy way. First of all, the bandwidth wasn't, initially great, and we were like, wow, what the hell is going on? That doesn't make any sense. That was mainly because, once we figure out, it was the TCP over TCP. What's his name? Retransmission bug. I don't know if you guys are aware of it. I see some people nodding their head. We were using TCP or TCP, so what we had to do is that we needed to fairly kind of reconstruct and do some network engineering. So we configured a TCP over UDP, and then and also configured the send and receive buffers, right? To optimize. That literally optimized our speed 20 times. So we'll see, we'll do some pings and stuff. Right now, we'll show you how fast that is now and all that. Another problem is that the DNS forwarders also got replicated. This is kind of, we found that out. It took us a while to figure out what actually happened. And because those are, for the AWS DNS on this side, that was configured to work with the private, IPs on this side, they were kind of, the actual connection was fairly kind of, intermittent, and there was a lot of issues. So, so what we did is that as part of the deployment, we included a PowerShell to go ahead and delete the DNS forwarders and recreate the proper ones for the zone B. So once all of that was sorted out, everything was going very smoothly. So are you guys ready to see the demo? Yay! Let's switch over. First thing I wanted to show you guys is the reason why we have a console is so we can do demos like this, right? Nobody in their right mind works in a console, right? Anybody working in a console? Please don't do that. But we love you. Yeah, go on. So this is the setup that we have. This is exactly what it goes out and creates. It creates redundant DCs, NAT instances, RDGWs, which is your remote desktop gateways, which effectively, for those of you that are probably wondering, bastion servers that allow us to go ahead and get into respective servers and maintain them and all that sort of stuff. So it does kind of RDP over HTTPS into them, and then it connects with RDP to respective servers. And then you can go to the other one. So this is our North Virginia, the US East 1 region. And you can see the exactly same environment. However, we've named it differently so that you can tell difference between which one's which and all that sort of stuff. So this is DC3, DC4, NAT3, NAT4, RDGW 3 and 4, and nodes 3 and 4. So let's go ahead and let's show you first the actual DNS. and where we've actually updated the DNS forwarders. And then let's go ahead and let's ping this guy and see what do we get. So you can see we've done some tests already. We're on 75 milliseconds. This is now between one side of the continent to the other side, right? From US West to US East. We have had literally, it's been consistently always under 100 milliseconds, right? Which is pretty good, if you ask me. It allows for things like stretched farms and SharePoint, and a lot of other things that you normally wouldn't do. This is a type of latency that some people don't get between their very close data centers, never mind other things. So I think this is pretty awesome. And then let's show you how long it takes to actually copy. So we are just copying from one region to another. This SQL Server, it's a 3 gigabyte file, right? And you can see it's going into 10, 8, 9, 10, 11. So that's megabytes per second. To put it in megabits, that's times 8. So it's around 80, right? If you look at that, that's if you divide it by 1.5, we have how many? T1s, yeah, 50 or so, some T1 connections between the two, which is pretty impressive, right? Looking at that. So what do you guys say to that? Pretty good stuff, right? This is pretty fast, pretty performant VPN connection that we have going on between the two regions. Okay, so let's get to the good stuff. So here we are. We are in a SQL Server availability group. And as you can see, we have configured WSFC node 1, 2, 3, 4. Primary one is node 1. I do have like a little laser here. Primary one is the node 1, you can see, and we've configured things like 2 automatic failover mode. So one in automatic failover mode, one in manual, actually 2 in a manual, so 2 and 3 in the manual, these two. So WSFC node 1 is failing over to node 3. So we can go ahead and simulate this. And you can see the synchronous and the asynchronous ones. Who knows how many synchronous can you have always on availability group scenarios between how many nodes? How many synchronous nodes can you have? 3. Thank you. Good. And how many of those can have automatic failover? Well, 1 basically. Yeah. So here we go. You can see we're failing over to WSFC node 3. So fun fact on that, with SQL Server 2016, which you can actually now use. We have Windows 2016 with SQL Server 2016 as part of our EMIs. You can go ahead and test out those instances. With 2016, you can have actual 3. So all the synchronous ones can actually have automatic failover. So that's one of the things that 2016 has as an improvement. Another thing that it has is you can create 2 separate always-on availability clusters. You don't have to create them over the whole thing, and they're domainless. You don't have to worry about them being on the same domain. And then you can then create a always-on availability group that can then fail over for one always-on availability group in one domain to the always-on availability group on the other domain. That's another thing to consider around the new feature with 2016. Another thing is, oh, here we go. We went over. Good stuff. We verified that we are running. I think it needs some refreshing to do. We'll eventually get there, right? Another thing to consider in the past, depending on your on your version, you could do. You guys are familiar with failover clusters for SQL, right? So and what the difference is between always-on availability groups. With failover clusters, they had shared storage, right? Whereas, the actual data replication was happening in always-on availability groups, which is kind of an evolution what mirroring used to be. Anyway, you could actually do something similar in a sense that you had 2 always-on availability groups, and you could actually create a failover cluster between 2 of them, and then treat that like 2 separate nodes, and then fail over between the 2. But they had to be on the same domain and everything. Okay, so it's still refreshing. Oh, we're failing back. Excellent. Oh, look at that. So we already failed over, and now we're failing back. Did you see that? It was literally in seconds. Wow. While I'm talking. So that's pretty impressive. I mean, when your downtime amounts to this, when your downtime, so the next thing would be just flipping over your DNS record to go ahead and point, to AWS or to a different region. And just like this, as you can see, here we go, we're up and running. Just like this, you can then, you can kind of deploy and create and fail over to additional regions and go on and on and on and on and on, right? So this is exactly coming back to the actual diagram. Right now, we failed over to from region A to region B. I think our probably copying is also finished at the same time. You can check it out. It's almost there. Yeah, you see it's going up and down and coming. Thanks to us playing around with failing over twice from one region to another. But we've effectively failed over to region B, and then with a simple, like I said, either enforcing the health rule check to go ahead and swap it over, or actually just flipping over DNS or Route 53 in this case. We could have gone on this side. Otherwise, what we did, a minute later was just fail over back to region A, and that's it. This is fairly impressive, fairly fast way to actually do so. Some of the I'm trying to think. I mean, if there's any specific gotchas besides the ones that we tell you, I mean, we can actually show you. Go ahead. We can show them the actual code. For those of you that are probably familiar with the actual CloudFormation stack, this is where the resources where we actually specifying what resources, and this is specifically, this is the EC2 instance for installing OpenVPN. You can see the config sets for CFN in it, where we have install open, configure OpenVPN, start OpenVPN, and then we have also an update config set for to install VPN, configure OpenVPN, stop and start again. And you can also show where we actually going ahead and removing the DNS server forwarders. We have, wait completion, and then afterwards adding the new or proper DNS forwarders in this particular case. So this is basically the add-on. This is the thing that you're not going to find, in the script that is available outside, but we will share it eventually after reInvent. If you look at the actual, what it looks like, if you go to the quick start, if it's there, yeah. So this is the quick start. You just go down to where the Microsoft options workloads are, and you can just click on here, deploy. And here you can just download this specific. You can see that it's specified in this S3. However, if we go next, if you were to then use it, or you can see that we have pre-populated some of the values to kind of make it easy for you. And you have everything from specifying and configuring domain controllers, configuring your SQL, configuring, and you'll see also with things like CloudFormation templates for SharePoint and so on. It will be also for configuring SharePoint and all of that. For configuring Windows Server failover cluster, and selecting particular nodes. You can go ahead and obviously change these to the values that you need. This is an auto-generated form from the properties in the CloudFormation itself, and then you can use that. Now we didn't create one that kind of encompasses both the region A and region B. We kind of manually created or deployed first this, well, similar to this CloudFormation, and then that also included the OpenVPN configuration, and then including the routing over the VPN between the two VPCs, as well as the peering between two. So that's literally it. I mean, from the demo, for what we wanted to show you, this is simply what we would like you to take home with you, and something that we would like you to test out and see. We encourage you, like I said, to do this also with enterprise workloads, as well as your application workloads that you may have, any .NET applications and so on. I don't know, we can open it up. We do have some time. If you guys want to, if you have any questions, go ahead. Thank you very much. I see the guys. Thank you very much, guys. If you want to come closer, do you mind? Yeah. So all of you that have questions, please come see us here. Thank you very much.